hear me?
Yes.
All right, cool. Are there any questions you have?
Do you have the homework with you, or do I
I
have
do.
to tell you? Okay, so we're doing just decide whether the relation is a function or not, and um,
Mm-hmm.
wait. It says I don't know, but it says domain notation. Your consult textbook. What does that mean?
What was that?
It says domain notation. Your consult textbook.
Do you have the textbook?
I have it downloaded on my computer, but
Mm-hmm.
I don't
Then
get what it says domain notation.
do you know what domain means?
No, not really.
Well, I think you should, like, you learn in class that the domain is just
Oh
all
yeah,
of
the
the
domain is it's like the first number of the parentheses in the parentheses of the code.
well, the domain is just telling you all of the possible values that x can be. So for example, if we have something like a parabola, right? Or no, okay, let's do it this way then. If you have a parabola going like this, okay,
Mhm.
and this point here, let's just say it's like, I don't know, 0, 4, whatever. So all the domain, it tells you, what x can be. So if you look at this, look at the x-axis and look at the y-axis. So if you look at all the possibilities for x, it's like all along here, right?
Yeah.
So you could, x can be 0, it can be like 1, it can be 2, whatever, blah, blah, blah. As long as it's something it has a value it can go to. So all the domain is telling us is what x can be. So in this case, the domain would be all the values greater than 0. Does that make sense?
Kinda.
Okay, well, just think about it like this. Just imagine how the shape of the graph.
Oh yeah, I get it. I get it.
So yeah, so this this point here, like let's just say it's like -5, 0 or something. If x is -5, is there like a point that it can go to on the graph?
Well, no, because that
No,
would
right?
be
So that's outside of the domain. So starting
yeah.
from 0, it has a value it can go to. So that's just the domain. Do you know what the range is?
Range is I think the y.
Yeah, so it's just what y can be. So let's just look at this for example, this parabola. So what would the domain be?
The domain.
Mhm.
Can you repeat the question, please?
What would the domain be?
Oh, like in that.
Mhm.
So the domain would be 0. It would just be 0, right?
So the domain just tells you all the possible values of x. So is 0 the only possibility?
Now there's like 1, 2, 3, 4.
Yeah, it goes all the way up to infinity, right? Because this
Yeah.
graph goes on forever and ever and ever. So what does that mean? It means the domain is just set of all numbers from 0 to infinity. And have you seen this before?
Oh, now
Okay.
I get it.
So all this is telling, if it's a bracket like this, that means it includes it. Honestly, I don't really
Okay.
remember like the notation and stuff, so that's why it's telling you to like look at the book. It's either this
Okay.
or this, but you can check the book for that.
Okay.
So yeah, that's what the domain is telling you. And then so for the range, what do you think the range would be?
The range would be it would just be 0 to infinity, right?
Um, well, it wouldn't be because wait, hold on. Um, so it wouldn't just be 0 to infinity because like this thing is going on forever and ever and ever, and it's stretching out, right?
Yes.
So that means that the domain is just all possible numbers. Does that make sense?
Kind of.
Okay. All right. Are there any other questions?
So let me quickly check.
Okay. Oh, and Gabe, we were just talking about what the domain is and what the range is. So, the domain is just all the possible values of x, and the range is all the possible values of y. So if you have
Okay.
something like this, what would the domain be?
Domain.
It's
Oh.
isn't it infinite?
Okay, so
I think.
if you look at this graph here, so
Yeah.
the domain is just telling us all the possible values of x. So
Mhm.
if you look at a point here, like let's just say it's -5.
Yeah.
Is there a corresponding value of y in the
No.
graph? No, right? So that means it's not in the domain because it doesn't have a
Oh.
matching pair. So
Okay.
starting from where does it have a matching pair?
0.
Yeah, 0. So the domain would just be like from 0 all the way up to infinity.
Okay.
That's how.
And I have a question on a problem or multiple problems on homework.
Mhm.
So the problem is it's y equals x minus 7 over 11.
Okay.
And then and I need to find if it's a function or not a function and what the domains are.
Okay.
So I
Do you
don't know how
know
to do that.
do you know what number this is?
29.
29. All right, I'll look for it right now. So does it look like this? Does this look right?
Yeah.
Okay, cool. Number 29. Do you know what chapter this is from?
I think is not in the book. I think
Oh. Mm-hmm.
it looks like one of the quizzes, but
Okay.
yeah.
All right, 1 second. And also, does what I wrote down, does that look right?
Yeah.
Okay. Well, so if you look at this, we can multiply both sides by 11, right?
Yeah.
So what do we get?
11y equals x minus 7.
Okay. And then can you make it look like something like y equals mx plus b?
Oh, is it y equals 111x
Mm-hmm.
minus 7/11?
Right. So looking at this form, it's just a line, right?
Yeah.
So is the question asking, what is the question asking again? Sorry?
It's a multiple choice question and it's asking what is it a function or not a function and what the domains are.
Okay, well, this is clearly a function, right? Do you know what the
Yeah.
definition of a function is?
Yeah. If well, I don't know the definition, but I know what like it is. I don't know how to explain it.
So, a function, just in math, it's just a relation. So it's a way of relating x to y, and
Okay.
it's just a way to get put in an input and get an output. So all the possible inputs is the domain, and then all the outputs is the range. So
Okay.
do you know how so like yeah, okay, so this is a function because each x corresponds to a y and things like that. So this is not really accurate. I just did a random line, but since it's a line, we know it's gonna look something like this, right?
Yeah.
Okay, so it's asking for the domain. So if you just look at a straight line, what are the possible values of x?
Is it negative infinity and and infinity?
Mm-hmm. Yeah.
So the answer is a function, and then the domain is negative infinity and infinity.
Yes. Mm-hmm.
Okay.
Are there any other questions from either of you?
No.
Okay. Do you know how in a function each input has to have exactly one output?
Yeah.
Okay, so for example, if I asked you a question like this, if I gave you a graph and let's say like this is 10, if I gave you this line, do you know what line this is? It's going like that. And if it's horizontal?
Then it's
How about this one? Let's look at this one instead. And let's just say this number is 10. So if it's going straight up and down, what do you know the graph of it?
No, not really.
Okay, so this graph would just be x equals 10. Does that make sense?
Okay.
It's just saying that
Oh.
all values y, x is going to be equal to 10. All right,
Okay.
so this is a question. Is x equals 10 a function?
No.
Right, it's not a function because,
All the x's are the same.
yeah, so there has to be at most one y value for every x value, but they all share the same x value.
Okay.
All right, cool. Are there any other questions?
Yeah, I have a question on another problem.
Mm-hmm.
So it's question 32, and the question is x equals y squared plus 2.
Okay.
And the question is the same as what is it a function or not a function, and what the domains are.
Okay. All right, so do you think this is a function?
Well,
Can you graph this? Do you know what this might look like?
no, I don't know how to graph it.
All right, so do you know what the x equals y squared graph looks like?
No.
Oh, you don't? Do you know what
No.
y equals x squared looks like?
No.
Okay, so y equals x squared. You know how we studied quadratic and everything? We learned how to factor
Yeah.
stuff. This
Yeah.
is just a parabola, and it just looks like that.
Okay.
All right, so it's like, when 0, it's 0. When x is 1, y is 1. Minus 1, it's also 1. So that's how it looks.
Okay.
All right, now do you know what x equals y squared might look like?
I think it would look like the same thing except on the side.
Yeah, it would just be a sideways parabola. Okay, this is not completely accurate, but that's kind of what it looks like.
Yeah.
That's that, and that's that. Okay. Do you guys know about do you remember when you learned how to graph linear things and like y equals x is here, but then y equals like x plus 2 would be like 2 to the left or something like that?
Yeah.
Okay. Well, it's exactly the same. So here it would be like 2 to the left, so it would look like this. So here it would be exactly the same, but instead we're moving this thing 2 to the left. Does that
Okay.
make sense?
Yeah.
So let's move it to the left a little bit.
Okay.
All right, now looking at this, do you think it's a function or not?
Wait. It is not a function.
Yeah. Do you know about the vertical line test?
The what?
The vertical line test?
No.
All right, so this is just a super, super easy way to tell whether or not it's a function. So if you draw a vertical line anywhere
Yeah.
and it hits more than one,
Yeah.
that means it's not a function. Because for x,
Uh.
there are two possible y's, right? And that's not,
Yeah.
that goes against what a function is. Let's look at this straight line. If we draw however many vertical lines, are we ever going to meet more than once?
No.
No, never. So this is a function.
Okay.
Here, like this one, are we going to meet more than once?
No.
Oh, yes, we are. Look, it meets infinitely many
Oh.
times. That's why we
Okay.
said this wasn't a function, remember?
Oh. Okay.
All right, going back to this. So is this a function or not?
No.
Yeah, it's not a function for sure.
Okay. So would the domains
Mm-hmm.
be wait, would it be 2 and infinite?
So yeah, I think, yeah. So it would be like 2 to infinity, I think.
Oh, okay. I get it. Thank you.
No problem. I think that's right. Oh God. Again, I'm not positive on this one, like the ending part, because I don't really remember, but you can check your book for that stuff.
Yeah, I'm pretty sure it's the answer.
All right, cool. Are there any other questions?
I mean, I have questions.
Okay.
So, these ones, like these y equals something something, I don't know how to solve them.
What do you mean solve them?
Like to find them as a function and find the domain.
Okay, so I just told you about the vertical line test, right? So does that make sense?
Not really.
Sorry, what was that?
Not really.
So what doesn't make sense about it?
Well, I don't know how to determine if it's a function or not with 6x equals 6 minus 2y. Like those kind of things.
So again, all you have to do is, or was it like this? I don't really remember, but all you have to do is graph it, okay, and do the vertical line test. So for this one, you can already tell it's going to be a line, right?
Yes.
Just has one x and then one y, so it's going to be a line. I think it's just like some positive line. It doesn't really matter what it looks like. All you know is that it's a line, right? So it's if it's linear, do you think it's a function?
I think it's a function.
Okay. Just do the vertical line test. For every x, there's just one y. So it works. It's a function. Now look at the graph. Imagine this is a graph, and tell me what are the possible values of x?
6.
If this
No,
line stretches on forever and ever and ever, what are the possible values of x?
just infinity.
Yeah, it's just all the way from minus infinity to infinity. Like I said, the vertical line test tells us that, right? We can do a vertical line anywhere, and it'll give us the same thing because it's going on forever and ever. We're only looking at a tiny little piece of it when we graph it.
Okay.
Does that make some sense?
Yes.
Alright, cool.
What about y equals x squared?
Okay, do you know what y equals x squared is? What the graph looks like?
Not x cubed, sorry.
Do you know what y equals x cubed looks like?
No.
Okay, so how would you figure out what it looks like?
I don't really know.
Well, just tell me some points on it. Plug in one thing and then tell me what y is. Plug in values for x and tell me what y is. Make a table. You can always figure out what a graph looks like if you plug in some values and then you can, look at the shape of it. All right, so you can choose some numbers or I'll choose them. All right, can you tell me what y would be?
Would be -2, 2? Not just -2?
Okay,
Or am I
so
wrong?
we're so here these are the we're plugging in x into this. Does that make more sense?
Yes.
All right,
So there would be 3. So it'd be -6.
all right,
Wait,
so
no.
it would be just -2 cubed, which is -2 times -2 times -2. So what would that be?
-8. Wait, -8, right?
Yeah, perfect. It would just be -8. All right, can you fill in the rest?
-1. Because
Okay.
1 square is the same. And then 0.
Mm-hmm.
And then 1. And then 8.
Okay, cool. So now let's try graphing it. It would just be -2, -8, look something like that. And then it would be like -1, -1, 0, 0, 1, 1, and then 2, 8. Does this look familiar?
Yes.
So y equals x cubed just looks like this. It's kind of like that. So if you just remember the shape, then it can get a lot easier. But now that we have the graph, let's do the whole test and you can tell me if it's a function or not.
It's a function.
Right, it's a function.
And the domains would be 0 to -infinity. Wait,
So just look at the graph and look at the x-axis, okay?
in -infinity and infinity.
Yeah, it would just be -infinity to +infinity because it can be anything. Stretches on forever and ever. All right, cool. Are there any other questions?
So, for what about the fractions ones, like y equals x minus 7 over 11? I didn't really get that one when H was doing that.
So this isn't really a fraction because if we move it to both sides, we can see we can rearrange everything and it's just a linear thing. Does that make sense?
Yes, kind of.
Okay,
So,
well, mhm.
do you have to put it like that?
I mean, you don't have to. As long as you recognize that this is linear, you can tell because, you have y and then you have x and just numbers. If you rearrange it, you can always tell that it's just linear. That's why we rearranged it. So we knew it was a line. Knowing that if we have a line, then we can do the vertical line test and tell that it's a function, and then, we can tell what the domain is too. Does that make sense?
Yeah.
All right, cool. Are there any other questions?
So how would we? Okay, so with that, how would we find? Well, how would we graph that? Would we place it as a fraction when you graph it?
Well, do you know how to graph something like y equals 1/2 x?
No,
No? Yes? What was that?
no.
Okay, so it doesn't matter what's in front of the x. This is just the slope, right?
Yes.
So all that's telling us is that the slope is, small. And if the slope is really small, that means that you have a really steep graph. So for example, can we do that thing again where we plugged in numbers?
Okay.
All right, so when x is 0, what's y?
Half.
When x is 0,
It would be half. One half.
so if you plug in x is 0, would we get 1/2?
It would just be 0.
Yep. So when x is 1, what's y?
One half.
When x is minus 1, what do we have?
Negative half.
All right, so let's put it here. When x is 1, let's say 1 is here, then y is 1/2. When x is minus 1, y is minus 1/2. So the line looks like this. It's just a very steep line. Does that make sense? It's not
Yes.
any different from graphing y equals x, graphing y equals 2x, graphing y equals 4x plus 6, whatever. If it's linear, then it has the same shape. It's always going to look like this or this.
Okay. What about xy equals 9?
Xy equals 9? All right.
Yeah, I also don't know how to do that.
Okay, so for this one, we can rewrite it as y equals 9 over x. Okay, first of all, do you guys know what y equals 1 over x looks like?
No.
No,
You guys, I'm pretty sure you guys did this in class.
we did.
Does this, okay, let me know if this looks familiar. Oh god, this is whack. Okay, here. Doesn't that look familiar?
Sort of. Isn't that not a function?
Um, I think this is a, hold on one sec. Is it? Well, this would be a function, wouldn't it?
But wouldn't that line meet once?
No, no.
Or
Okay, so
not?
do you guys know what an asymptote is?
No.
All right, so an asymptote is when something goes on forever and ever and ever. So, for example, here I'll rewrite it. So, okay, so if we have a graph, let's just draw that one again. It was like y equals 1 over x, right?
Yeah.
Okay, so let's go on forever and ever and ever and ever, forever and ever and ever. So what this is doing is here, x is going, it's getting bigger and bigger and bigger, right? And y is getting smaller and smaller and smaller as we go to the right. But in this graph, it's never ever going to be 0. Do you know why? Why don't we try plugging stuff in? So what's a really big number you can think of?
Wait, any big number?
Yeah, any big number.
69.
Okay, 69, sure. So 1 over 69, where is it going to be? It's going to be, let's say it's somewhere around here, right?
Wait. Huh? Why wouldn't it wait, actually never mind.
I just made it up because then it doesn't really matter where it is. So let's say it's there.
Okay.
Do another huge number like 563. Where it's going to
Okay.
be? It's going to be farther to the right. We go to a million, whatever. It's going to be farther to the right. But here's the thing. Is it ever going to reach 0?
No.
It's never going to be 0 because that would mean that 0 equals 1 over x. But can that be possible?
I don't think so.
Yeah, that's not possible unless, it's approaching 0, right? As x approaches infinity, it gets bigger and bigger and bigger. Y is going to go to 0, but it's never going to be 0. That's just not possible.
So wait, so they're not, so this is a wait, no, this is a function.
Yeah, it's a function.
Okay.
Just do the test and you'll see it meets only once.
Okay.
Now, what would the domain be of the function?
Wait. Is it infinity and negative infinity?
Well, what's the one value that x can't be?
0.
Yeah, so it's everything except for 0. Just x cannot equal 0.
Okay.
All right, cool.
Wait, does that mean the domain is not 0?
Yeah, we can just write it like, you can use your set notation, which would be like minus infinity to 0 and then like 0 to infinity or something like that.
Okay.
Or where this is like not including it, but like it's way easier if you can just say x does not equal 0 because that's the domain. It's just all numbers except x can't be 0.
All right.
I think you would use, do you guys know like the cup cap thingy?
No.
Okay, you'll probably learn it. This is just like a union. So all this is telling us is it's just linking them together. So it would just be that. All right, do you know what the range would be for this?
No.
Okay, so what's the one value that y can't be?
Is it 0?
Yeah, it's never
No.
going to be 0 because
Oh,
if you have a fraction over whatever, it's never going to be 0. So if this is the domain, then the range is also going to be like this. And you can also write it like this. I don't know if you've learned this notation yet, but you can do it because it's the same thing. Just use whatever like the problem tells you to, but you can also do this. So it's like this. So this is just telling us, and then x cannot equal 0. Here it would just be y, and then y cannot equal 0. It's telling us the same exact information, just a little bit neater, I guess. So you can use whichever one you like. Okay, are there any other questions?
wait. I have one more question.
Mm-hmm. Yeah, go for it.
So for 34, are we supposed to write the domain and range?
I don't know what number 34 is. Can you
Oh,
tell me
wait,
what it is?
so, wait, never mind.
Hmm?
Never mind. I was confused for a second, but now I get it.
Okay, cool. All right, let me give you guys a question. You're probably going to learn about this later, but this is just a circle. It's the graph of a circle. So looking at this, do you guys think it's a function?
I don't think it's
All right, we have a vote for it's not a function. What do you think, Gabe? Is it a function or no?
No.
That's not a function. You both got it right because the
Yeah.
vertical line test told us it's not a function. All right, cool.
Yeah.
Are there any other questions?
Yes.
Okay, go for it.
So, I think I know how to do it, but
Mm-hmm.
I'm pretty sure I got it.
Okay.
I have a question.
Mm-hmm.
It's y equals 2 over x plus 3.
Like that. Does it look like this?
Yes.
All right, cool. Okay, so for this one, what can y not, or what can x not be?
0.
Or, well, if you
Well,
plug in x equals 0, what does y equal?
2/3.
Yeah, y is just 2/3, so it's completely fine if x equals 0, right? What
Yeah.
we're worried about is if the denominator equals 0. So just if you're trying to find the domain of something like this where it's in the denominator, all we have to do is
Yeah.
set the denominator equal to 0. So if we do that, what do we get?
-3.
Yeah, so x cannot be -3. That's it for the domain. And it's the same thing for the range, except we already know what's the range going to be then. This is
Wait.
so what's the one value the y can't be?
0.
Yeah, so just y can't be 0. And again, we can write it in the whole set notation. It would just be like X. And then here it would just be like this. Does that make sense?
Okay.
All right, cool. Are there any other questions?
no. Well, I don't, at least.
Okay. You can ask about anything. I'll just be here until around 5.
I'm just gonna like slowly do my homework and hold on, I'm gonna ask you questions.
Okay. I'll be here until 5, so you
Okay.
can ask until then. That's fine. If you have any questions, you can go ahead on mic. So yeah.
So for 28, it's x equals y exponent 6. I got the domains right, but I don't get why it's not a function.
Okay, so let's okay, first of all, if you know that it's x equals y to the 6th, all right, let's try plugging in some numbers, okay? Let's do, this is x, this is y, 0, minus 1, and then 1. So tell me what y would be.
Y would, oh, I put zeros, x is 0 and y is 0 and x is 1. And, well, okay, never mind. So 1 would just be 1. So x is -1 and y would be -1 as well.
Y would be -1 if it's an even power.
Oh, it would just be 1.
Right, and it would be the same for y. So
Yeah.
look at this. So we have two different x values, right?
Oh, I did something else. I did x. Okay. Thank you. Now I get it.
Oh, okay, cool. Wait, is this right? Hold on. Different x. There's a different y values of the same x value. Well, either way, I think if you look at the graph, it should make sense, right?
Actually, it's just like it's like a
Hold
little
on. Oh,
U.
sorry, my bad. I was doing it wrong here. There, I was supposed to be doing that. So when y is -1, x is whatever, and then oops, and then y is 1. That's, yeah, that's better, I think. And then it would, let me actually see what the graph would look like for this. I'll try to draw it if I can. Where's my graphing calculator? Okay, here it is. I think it's out of battery. Let me go on here. Yeah, let's just start calculator. Okay, let me. Can you see this?
Yes.
Okay, so on the left, I'm just going to graph this, and it looks like. All right, so it looks like that. So you can clearly tell that it's not going to be a function because for one x value, there are two possible y values. Yeah, so when x is 1, y could be either -1 or 1, and that's that means it's not a function, so it's not going to be a function. And then does it ask about the domain and range? Or no?
Can you repeat the question, please?
Does it ask about the domain and range? Like, do I need to do that or no?
It only asks for the domain and whether it's a function or not.
Okay. All right, so just from that graph, it looked something like this. And also, this is it's to an even power. So knowing that no matter what y is, x is always going to be even, right? Unless it's 0. So do you know what the range would be? Or not the range, sorry, the domain.
So the oh, sorry, I was muted. So I would think the domain would be just infinity. Is that right?
So do you remember the definition of the domain? It's just all possible x values, right? Can x be anything from minus infinity? Can it be like, can x be minus whatever here is minus?
No, it can't.
Yeah, so from where does it start to?
0.
From 0. So what's the domain?
The domain would be 0.
So the
Right.
domain is telling us a range of values. So all the possible values. Is 0 the only value?
No.
Mm-hmm.
It's 0 to infinity.
Yeah, so it's just 0 to infinity, like you
All right.
said. Does that make sense?
Yes.
All right, perfect. Are there any other questions?
Yeah, I sort of have a question. So I want to know,
Mm-hmm.
well, I'm a bit confused on how to, or actually, I'm just confused on question 30.
Mm-hmm.
I'm still confused. It's y equals -2 over x. And I don't know what to do from here.
Okay, so this one, you can notice it's in the form like y equals 1 over x. It's just another one of these problems.
Yeah, but, wait, never mind.
So if we, let's try going to the thing. Let's look at the graph. Let's go ahead and delete this one. Okay, y equals -2. Where's the fraction? Wait, whatever. -2 over x. All right, so you can see, remember from before, for y equals 1 over x, it looked like this.
Yeah,
So if there's a,
it's a function.
yeah, this is a function. If there's a minus sign, all that means is we flip them so it looks like this.
Okay.
Okay, then. That's cool. Anyway, so it's of this form again, but nothing really has changed, right? Because it's the same in that, it's still going towards 0 but never reaching it. So remember what we said before about how the denominator can never be 0.
Okay.
So knowing that, what would the domain be?
It would be, wait, is it negative infinity and 0 with and 0 and infinity?
Yeah, so it would be like the union and then
Okay.
0 infinity. So in other words, if the more simple way to write it is just x cannot equal 0.
All right.
Like this.
Thanks.
No problem. And then of course the range is just going to be the same thing because it can't be 0. Or we can write it like this, y bar and then y cannot equal 0. All right, are there any other questions?
I have a question on 20. Well, I still don't get how you do 29 and 31.
Wait, 29 and 31?
Yes.
I don't have a problem. Could you?
Oh, okay. So it would be y equals x 11th minus 7 11th.
Sorry, could you say that one more time? Why?
You did this before, and it was like y equals x 11th minus 7 11th.
Okay, what do you want to know about this one?
X over 11 minus 7 11th.
Yeah, what's the question?
Oh, it's not 1 11th x. It's x over 11.
X over 11 is the same exact thing as 1 over 11th times x.
Oh, okay. Sorry.
No problem. I just wrote it like this so it's easier. You can see the slope.
Okay.
Yeah. So, do you have any questions about this one?
Yes.
Is it like about the domain or the range or?
Domain and the function. I don't know how to like find the pairs. That's it.
Okay, so first of all, this is linear, right? And we know that because it's just y equals something x plus something. So if it's linear, we can, as long as it's linear and it's not something like this, then we can just assume that it's a function. But if you wanted to graph this one, what would you do? Do you know how to graph a linear function? Did you guys learn that?
No,
Didn't we do it last time? Remember?
you did?
Yeah,
Well, can you do some? Because I might have to refresh my mind.
yeah, sure. But remember all this we did?
Oh, yes.
We graphed all these, and those.
Yes.
How did we do that? All you need for a graph that's linear is 2 points.
Yeah.
What are the easiest points we can get?
Negative 7 11ths and 1 11. Well, no. Wait.
So do you remember what the y-intercept is?
Y-intercept would be, I forgot.
All right, no problem. As long as you can remember now. So the y-intercept, it's just telling you when x equals 0, what is y? And it always tells us if we write it in this form,
Oh,
the
yeah,
right
and
form.
then, yeah.
So it would just be minus 7 11ths. Now what's the next super easy point we can get? It's always the x-intercept. So what would the x-intercept be?
0, and then y would equal, wait.
So the y-intercept is
It
when
would be 1, but it would just be 1 11th, right?
No, this is telling us the slope.
Yeah, I know, but like, what if so if y equals 0, then wouldn't x be 1 11th? Wait, no.
Well, let's try it
Oh,
out.
that's
So
slow.
if y equals 0, then we get 0 equals 1 11th x minus 7 11ths. Now what do we do?
Um, I don't really know.
Well, what do we always want to do when we're solving for x? Do we want all these things on the right side?
No, we want it to the left.
Okay,
So it'll
so
just be 11 parentheses 1, just x minus 7.
okay, well, first let's just move this to the left side. Let's try subtracting 1/11th x from both sides. We just get equals minus 7/11. All right, so we can always cancel the minus sign if it's on both sides. And we can also multiply both sides by 11. So what do we get?
We would. Wait, no, wait. Oh, it would be 77/11. So it would equal 7.
Yeah, so all we do is we get x equals 7 when y is 0. And then we got y equals this when x is 0. So all we really need are 2 points when we're graphing something linear. So let's try graphing it. So where is 0 minus 7/11? If this is like minus 1, then let's just say it's somewhere, I'll put in red, around here. And then the next point, it's when x is 7, so maybe like around here-ish, and then y is 0, so let's say it's right there. Now let's just graph it. And then that goes through both points. And that's the graph. So that's how you graph it. It's exactly the same as doing any
Okay.
other kind of linear thing. Just it gets tricky because you know the fractions and stuff, but yeah,
Okay, thank you.
no problem. Okay, so are there any last questions before we wrap up?
No.
Okay. Okay, no questions, then I think, yeah, okay. Well, thank you for coming. Feel free to
Bye.
ask. Okay, bye. If there are any last questions, then I can answer them. If not, that's fine too.